So we talked about equations before, yeah?
Yeah.
Who can tell me what makes something an equation?
It has an equal symbol.
Has an equal symbol, right. What if it doesn't have an equal symbol, but it's an algebraic thing? It's called a...
Term.
Be careful. It's a collection of terms. It's called an...
Expression.
An expression. There you go. They're made up of terms, you bet. But it's an expression when there's several of them strung together. Good. Okay, so what we're going to do today is we're going to formalize the rules for solving linear equations. Now, we've talked about linear before. Linear means that if you drew the graph of it like we did on that test, it'd make a straight line, right? Okay, line up in a straight line. And that's why they're called linear. And again, they're called equations because they have equal symbols. And I'm going to give you all of the parts, although in this course, we don't really work with ones that have fractions in them. But we can, if y'all want to do them. But we're not going to start there. So we're gonna move. But I am going to put the directions there for you because think about it. Is it easier to learn one way that works all the time, or do you want 50 different shortcuts?
One way.
Yeah, right? Now, if you know that one way, does that mean you can't ever take a shortcut when you recognize it? No, you can absolutely take shortcuts later, right? But if you stay focused on that one path, then you know where you're going, you can see shortcuts because there are tons of them. And you'll see them as you move forward in your algebra career. You're going to see that some of the shortcuts are really, really useful. Okay? There are lots of special cases where it will make your life fast if you know the shortcut. But it's bet you still have to first understand where you're going. Okay? Does that make sense?
Yes.
So when Education Perfect uses a shortcut, you're not going to yell at me and say, Mr. Self, why didn't you just show me that shortcut? That took a lot less time. No. Well, you might, but I'm not going to listen to you, so it doesn't matter.
I do that to my dad a lot.
All right. Here we go. Pardon?
I do that to my dad a lot.
Yeah, do you? Just tell him you found there's a shortcut. Well, it's okay. Because remember, as the problems get bigger, that's why. All right, here we go. So we're going to talk about solving equations. Now, some of this we've already talked about when we did that little section on balancing equations. Remember where we looked at some of those rules? First of all, we know that it's an equation because it has a what? An equal symbol. Good, I like it. This symbol is the right word, but you can also say what? Sign. I'm not going to yell at you if you do. But technically, what's a sign? Positive or negative, right? Those pluses and minuses are signs. The symbols, mathematical symbols, that's what an equal symbol is. Okay? So it has an equal symbol. And remember that we can solve equations, but we can't solve expressions. Expressions we might be able to simplify, which means do a little math, right, and make it smaller, but we can't solve it. But we can solve an equation. And we know that it's solved when the variable is completely by itself. And that's how you know when you're done. Because sometimes in mathematics, it's difficult to understand when you're finished. But here with equations, then we know we're done when we're finished, when everything equates things by itself. So what I want to do is I'm going to put a couple of things up here, and I want you to tell me, am I done or not? Okay?
No, not yet.
Here we go.
I'm totally a little bit done. It's math.
So here we go. So say I have x equals 5. Am I done?
Yes.
Yes, because the x is completely by itself, you're done. Okay? Don't let this one throw you. 7 equals y. Am I done?
Yes.
Yes, but the y's on the wrong side. Is there a wrong side?
No.
No. Now, many times your teachers tell you that it needs to be this way. There are two reasons for that. One is for some graphs later, it makes it a little easier if you have the numbers there. And another one is, let's say you were taking a test for me and you had all the letters in a row on this side and all the numbers on a row on that side. It would be easier for me to mark Sorry. Right? That's one of the reasons why teachers make you do that, though, is because it's easier to mark when if all the numbers are on one side. I don't have to pay attention, do I?
You just change the way we learn math.
Okay.
We learn math just so they can make it easier to mark.
Yeah.
That's evil.
It's evil?
It's resourceful, yet to
But you do need to realize, though, that if x equals 5, 5 also equals x. You can reverse them. It makes no difference, right? Okay? Okay. So this student is Siala, and Siala is this student. It doesn't change anything if you say it backwards, does it? Right? So it's the same thing. So the same thing is as true with these. So it doesn't matter which side your x or y or whatever is on. Okay? All right. 2x equals 10. Am I done?
No.
Why not?
Because it's 2x.
Because it's 2x. I needed to say x equals something, right? Ooh, be careful. Because,
It's 5.
yeah, there you go. Because you would divide. Yeah, see. Actually, there you go. All right, here's one that's going to mess with you. Negative y equals 20. Done? There's something over there with it. I don't want anything over there with it.
Y equals minus 20.
There you go. Exactly right. No, it would be negative 20. We're not worried about y right now. They just don't, if you're not seeing it, don't worry. They're just spouting out stuff they already know. All right, now, so, okay, not done until the y or x or whatever is what? Completely by itself. Okay? And the method, so that's what we're trying to do, is get the y completely by itself. And the method you're going to do to accomplish that is the opposite operation. Now, this we talked about before when we were talking about balancing, right? Opposite operation. So if two things are connected with addition, what's the opposite? Subtraction. If they're connected with subtraction, what's the opposite? Addition or plus. Say whatever you like to. That's fine with me. Multiplication, which y'all usually say times, right? Multiply would be what? Divide. Okay. And division would be? Multiplication. Exactly. So if you can tell how two things are put together, then you know automatically how to take them apart by doing the opposite. Okay? It's just that simple, if you'll let it be. Now, how do I know it's addition? You have a plus symbol, right? Okay? What if there's no sign at all? What do you assume it to be? A plus. So, if it doesn't have a plus, could you write a plus if it makes your life easier? And it might. Okay? How can I tell if something is subtraction?
If it has a
The minus symbol. Now that's the only way, right? Addition and subtraction are very fixed, aren't they? There's only one way to write addition. There's only one way to write subtraction. Now how about multiplication? Is multiplication always written the same way? No, remember for multiplication you got a couple of different ways you could go. 5 times x. 5x. 5 parentheses x.
5 asterisk x.
Yeah, but I can't draw one of those, so we're not doing it. Okay, but which one of those are you going to see most in algebra? The second one, there you go. Okay, and division, you can see a couple of different ways, right? Yeah, 5 divided by x, or 5 what? Over x. Which one of those is the most common way in algebra? There you go. Okay. Now, does that mean the others won't happen? No, they can happen, but so you'd be careful. So, I'm going to write down a couple of things up here, and I want you to tell me what the opposite would be. In other words, what would you do? What would it mean if you had plus 2? Add 2. The opposite of add 2 is? Subtract 2. Okay. What if I had this? What does that mean? It means right now subtract 2. The opposite is add 2. Okay. We're going to tell me what it means first, and then we're going to tell me the opposite. Okay. What if I have this? 5 times x. So what's the opposite? 5. Well, x divided by 5, right? It's 5 times x, so x divided by 5. Okay? Okay, there we go. You could reverse it. But if it comes in that order, let's go that order. All right? How about this one?
5 divided by 8.
And what's the opposite? 5 times x or x times 5. Yeah, because remember, you can do it in the order. Okay? Can you handle that?
Yeah.
All you have to do is identify the operation, and then you're going to do the opposite. The evil? Okay. All math is good. Okay. Are we all right? Are we good with that? Okay. Well, then what we're going to do is then we're going to do... Question?
So just wondering, with the 5 and the 8, so we catch what you're doing.
Okay. So this is 5 times x, right? So what's the opposite of multiply by 5? Divide by 5. This one is x divided by 5 divided by x. So the opposite of divide by x is multiply times x. There you go. 5 times x. There you go. Excellent. Okay? Great questions. Good. All right. Well, then what I'm going to do is I'm now going to write out a set of formal rules for us. And these are the algebraic rules for solving an equation. Now, this is the hardest part. You've got to know them, and you got to know them in order. And what happens is, to most students, it freaks you out a little bit, and you'll stop being able to do the good work you've done because you've got to know when, and you got to know what. Or, yeah, the how. What? All right? Okay? So, all right? So you've got to make sure. But we've talked about every piece, except for the fractions. We're going to deal with fractions right now. All right? But it's going to be in your notes.
Wait.
All right.
No, John.
Steps. Hold on. I'll show you why. Actually, there are a couple of fractions in your homework, and you can do them if you want to. And I'll show you how. But you're not going to be responsible for the fraction ones yet. Okay? But they're easy ones. All right, here we go. Ready? First thing we're going to deal with are, imagine that, brackets.
Oh, I thought you said it said walk.
Walkets?
So I thought it said B-U-A-C. And I'm like, what the heck is walk?
My spelling. All right, my writing. Brackets. Well, in the order of operations, what's the first thing you deal with anyway? Brackets. All right. Yeah. Okay. So, second thing we're going to do is, well, it's not that, so we're talking about the steps for equations, so it's a little bit different. So we're going to clear any fractions. Now, that's the beauty of equations, is that you don't have to work with fractions. Do you like working with fractions?
Yes.
Well, some of you do, some of you don't. I personally would rather work with a 2 and a 3 than a 2 over 3. So, you can clear the fractions. And we're going to look at some very simple clearing fraction ones, but we're going to keep it really simple, okay? Well, it's pretty easy to clear fractions, because what does the fraction bar mean?
Divide.
And the opposite of divide is?
Multiply.
There you go. All right. Third step. And there are only 5 steps. Okay? Third step. Get all number terms. I'm sorry, don't say number terms. I always say that and then I always change it. Get all variable terms. Variable terms on one side. All right, go ahead and take a second to write that down, and then let me explain what I mean. You can always put more notes in. Okay? Get all variable terms on one side. Now, first of all, let me explain this on one side business. The types of problems that we are working with are called what? Algebraic equations. Okay, all right. And what makes them an equation? And so that's what I mean on one side or the other. On one side of the equal symbol. The equal symbol kind of acts like a wall that separates the two sides. Okay? And we're going to be moving across that wall. All right? So on one side means either on the left or on the what?
Right.
Okay? So, does it matter? Nope. You do whatever you want. You want them on the right? Put them on the right. You want them on the left? Put them on the left. Who cares? But what you do have to remember is that these things are terms. Okay? These are variable terms. And what is the first part of every term? It's starts with an S. Sign. There you go. The sign, right? Which tells you that if the first part is a sign, in other words, a plus or a minus, then terms are always connected by addition or
Subtraction.
So how do you suppose you'll move them? Add or subtract. If it's a plus, you will subtract. If it's a minus, you will
Add.
Oh my gosh. Real rocket science, isn't it? Right? So if you see a plus, what?
You subtract.
If you see a minus, what?
You add.
It's getting hard yet? Okay. So you're going to move them by either adding or subtracting. Right? Now, the only time this gets really difficult is, what if you don't have a sign in front? It's a plus, right? So what would you use to move it? Subtract. So you can have terms that don't have a sign in front, and so you just have to assume, though, what the term sign is. Good job, guys. All right. Step 4. Get all number terms. Oops, sorry. Number terms on the other side. Get all number terms on the other side. Now, other side of what?
The equation.
The equation, the equal symbol. Good, okay? And by other side, I mean that if my letters are on the left, then my numbers need to go to the right. If my letters are on the right, then my numbers need to go to the left. Does it matter?
No.
Nope, just as long as they're on opposite sides. Okay? Now again, we're talking about terms. And the first part of every term is its sign. So that means they're connected with either addition or
Subtraction.
So how do you think you're going to move them? Add or subtract. There you go. Okay. So if it's plus 4, what's the opposite of add 4? Minus 4. If it's, I don't know, minus 2, then what's the opposite of subtract 2? Add 2. Okay. Now, last step.
Oh my gosh.
Oh, you want 2 seconds?
Wait.
Okay. Oh, yeah.
Wait.
Just messing with me. All right.
No, wait. Never.
Last step. Divide by the coefficient. Of the variable term. And I'm, okay. Divide by the, whoops, can't do that. I can't make my circles work. We'll just go to red pen. All right. Coefficient is simply a fancy word for a multiplier. Now, the multiplier of a term is always the number part. Okay? But remember that we said that the coefficient and sign are taken together as one piece. They tell you how many. So anytime you're working with the coefficient, then you automatically also include the sign. Okay? Now, they're not going to throw a lot of negatives at you at this stage. That's not the point. That's not what we're working with. But sometimes they can be. Later they can be. And so I just want you to get that through. And why would I be dividing if it's a coefficient?
Because if it's a multiplier, you have to subtract.
And I have to do the opposite. You betcha. Because coefficient literally means multiply. And the opposite of multiply is divide. Okay? You've just solved an equation. That's all there is to it. Now the whole thing is that you need to do it in order. Now here's part of the shortcut things that they do is they don't do them in order because sometimes not everything's up there, so they don't do it in order. They also really get lazy when they're writing out what you're doing. Now, when you're working with these, when they're new to you, and I know a lot of you have solved equations already, but again, we're going to build on them and make them bigger. So what I wanted you to do is I want you to follow every step and ask yourself every question. And I'm also going to model for you how I want to see it. Okay? Y'all are my class now, right? And we've been together long enough that y'all are comfortable with me. You know I'm not going to throw you under the bus, right? I'm going to do things. You don't know that. Trust me. Well,
Don't you know that's what we were
how you're going to do you were thinking of? All right. Stop it, messing with me. All right. Now, so I'm going to demonstrate this, model it for you. And when you do your education perfect work, then either in your typing that you do, if you want to type it in, that's fine. Just show your work. I want to see all of it. I would much prefer, that you wrote it on paper and just entered your answer in Education Perfect. Because writing something down triggers different mental capacities than typing.
It does.
And research has shown that students who write stuff with pencil and paper remember it better and do better than students who type it in. All right? Now, that might not be you. You might be like the world's best type it and remember it forever person. I don't know. But if you are going to type it, I'm going to look at it. Now, that's another thing. I'm going to start looking at your homework a lot because this is really, really, really important. And so I always look at your results, yes, but I haven't been sending you little messages when you don't do it.
You missed out majorly on that you need to read it.
Okay? But this time I'm going to start sending you messages saying, you have a homework assignment that you haven't started on. Is there a problem? Did I do something wrong? Did I not explain it well enough for you to understand? I always try to blame me before I blame you. Even though it's probably your fault. I mean, even though it's probably not your fault. Okay? Now, but because, remember, if you don't practice, you're not going to succeed, right? Okay? We all want to succeed. Okay, so now let's talk a little bit about, remember, those are the steps, right? But remember when we talked about balancing equations, we said that you can do anything. To an equation, you guys, to an equation as long as you do it equally. Equation equally, right? In other words, both sides. So could I divide one side by 5? Yes, as long as I divide the other side by 5. Could I multiply one side by 11? If I want to, as long as I multiply the other side by 11. Can I add 7 to one side? As long as I add 7 to the... Could I subtract 9 from one side? As long as I subtract 9 from the other. Could I subtract 5x from one side? Yes, as long as I subtract 5x from the other side. Doesn't matter what kind of term it is, as long as you do it how? Equally. Okay? That's the key. You're going to do the opposite and do it equally. Clear as mud, right? All right. So what we're going to do is we're going to do a few examples. And here's what I want to do. We're going to do some very simple equations here. I'm going to write down an equation and we're going to work it together. Okay? And we're going to work it together. And then I'm going to write down one that's just like it. And y'all are going to work on it. Solve it. Compare with your group. So you'll have a minute or so to work to do it by yourself. You'll have a minute to look at it with your group and compare to make sure you got the right answers. And if not, why, right? And then we'll do it together in class, as a class. Okay? So it's a completely safe place. If you don't know, you don't know, it's fine. But you need some answer. So if you're looking along and you don't understand it, then you say, how'd you get that 7? So, what's the theme? If you don't have an answer, steal one. That's why we work in groups, right? Because when I call your name, you're going to tell me something. Okay? All right, so here we go. Let's just do the first one together. And again, we're gonna do very simple here. Say we have x plus 2 equals 7. Okay? First of all, First of all, how do I know what kind of equation what kind of problem this is? Well, so let me rephrase that. I've already told you the answer and everything else. All right. I know that this is some kind of problem because of the equal symbol makes it an equation. So can I solve or simplify equations? Solve them, right? Good. Now, to solve an equation, go to my steps, and it says the first thing I need to look for are what? Brackets. Do I have any? No. If you think that it's going to be a problem for you, here's the way to make this work. You know it's an equation. So the first thing you look for are brackets. Don't have any. What do you look for next?
The clear fractions.
We clear what? Fractions has a K in it now. Did you know that? Okay. Fractions. It's German fractions. All right. Fractions. Do I have any? No. Then I want to get all my what? Variable terms on one side. Now, guys, make me proud because we've been talking about this for a long time. A variable term is any term that has a what in it? Variable or a letter. Yeah? So what is the only variable term up there? The x. Well, if I only have one of something, am I going to move it to get it by itself? No. Right? If you only have one of them, it's on one side. Now, it's not by itself, right? But it's on one side. Make sense? So no x terms to move. Then, what's my next step? Number terms on the other. Okay, again, make me proud here. We've talked about this. Number terms are just plain old numbers. And how many numbers do I have? 2. So I have a positive 2 and a positive 7. Okay, remember there's no such thing as anything without its sign anymore now when you're dealing with algebra. Okay, now, how many number terms do I have? 2. Means one of them has to move, right? Okay. Now.
Who's being voted off the ice?
Plus 2. You are. It's the positive 2. To be continued.
Why would I want to move the positive 2 instead of the positive 7?
Because the 7 is on the other side.
Right. My whole goal is to get that x by itself. And if you start moving stuff toward the x, are you going to get it by itself?
No.
Nope. We got to move the stuff what? Away from it. So since my x is on the left, my numbers have to travel to the right. And I do that by using the opposite. Well, this thing tells me to add 2, right? So what's the opposite of add 2? Subtract 2, which is perfectly fine, right? I can do anything I want to, but if I'm going to subtract 2 from this side, then what? I've got to subtract 2 from the other side. And that's what I want. Do you hear the terminology? Not subtract 2 from the 7, but subtract 2 from the other side. All right? Because I know it sounds like you should be specific, but you shouldn't. Trust me. Now, let's do the math. X minus nothing just stays what? X. 2 minus 2 makes a what? 0. But do I need to write x plus 0? No. X plus 0 is the same as just plain old x. That's the whole point. Right? Equals, what's 7 minus 2?
5.
Is my x by itself?
Yes.
Then we're done.
Yay.
How happy are you?
X is now alone now.
X is all by itself.
We've separated the x.
That's right.
From the 2.
It's all lonely and sad now. No, it's not. X wants to be by itself always. Okay, so here we go. I'm going to write one down that's just like it. You're going to have a minute to work on it on your own. a minute to discuss it with your group to make sure y'all did the same thing and you showed the same work, right? Don't just do it in your head, even though I know you can take 7 minus 2 in your head. Show the steps, right? Because later when you have to, you need to, right?
Yes.
You can do this, guys, for me, just please.
Okay.
For Christmas, give me this. Just give it to me. Y plus 4 equals 9. Go. Okay. Try to work on it by yourself first and then talk about it in your group. And remember, I'm a member of every group, so you can always ask me anything.
Can I ask you
About the equation.
What's the answer to the equation?
29.
That's why. That is done. It's 2:30.
Okay. Oops. We got time for one more. All right. Look at this one. So we have 5x equals 20. Ready? Go. Walk yourself through the process. 5x equals 20. Yeah. Okay. So, first, how do I know what kind of problem this is? Oh, sorry, just sing out anybody. Equal symbol tells me it's an equation. Good. To solve any equation, the first thing I look for are brackets. Do I have any? No. Next, second thing I look for are fractions. Do I have any? No. Then I want to get all my variable terms where?
One side.
How many variable terms do I have up here?
One.
Just one. What is it?
X.
Be careful.
5x.
5x, right. The whole variable term is what I'm talking about, remember? And a variable term is the sign, coefficient, variable, every bit of it, right? So, if I only have one variable term, is it moving? No. How many number terms do I have? One. What is it? 20. Now, 5 is not a number term. 5 is the what? Coefficient of the variable term. You see the difference? Now, so I've got my variables on one side, my numbers on the other. Is the x by itself, though? What does 5x literally mean? And the opposite of multiply is divide. So I'm going to divide both sides by the coefficient. What is the coefficient here? So that side and that side. Now watch what happens, guys. Listen. Right? 5 divided by 5. What does anything divided by itself make? 1. But that makes it 1x. Also known as x. You betcha. You don't need the 1. That's what's happening, but you don't need the 1, do you? Equals, on this side, 20 divided by 5 is?
4.
Is my x by itself?
Yes.
Then you're done. Okay? Look at how things are put together and take them apart by doing the opposite. It might look a little odd at first, but here is one point, especially in mathematics, where you just need to be very literal. If they're added, you will what? Subtract. If they're subtracted, you will? If they're multiplied, you will? Okay? All right. Okay, so let me